Hi guys, welcome back to Google Foundation online classroom channel. I understand it's locked down, but we have to continue. So basically today we'll be doing part 2 of functions. Let me take you through my presentation. Okay, now we'll be doing part 2 of functions. This is a quote by Albert Einstein. He said, education is what remains after one has forgotten what one has learned in school. Okay, today we'll be looking at exponential, hyperbolic function, exponential function, and inverse function. So the focus of the lesson today will focus on hyperbolic functions, we'll focus on exponential function, we'll look at inverse functions, we'll also look at some exam questions. So now let's start with hyperbolic function. So general formula for hyperbolic function is y is equals to a over x minus p plus q, whereby a will never be equal to 0, x will never be equal to 0, and y will never be equal to 0. So now let's look at the parameter a. A indicates the shape of a graph. When your a is positive, your graph will be at the first quadrant and the third quadrant. When your a is negative, your graph will be on the second quadrant and the fourth quadrant. Now, what is p? P is the vertical asymptote. X equals to p. Now let's look at q. Q is your horizontal asymptote. Now let's look at the intercepts. So this one I said x-intercept when y equals to 0 and y-intercept when x equals to 0. This is the game. That's how we play it. This is the hide and seek rule. Okay. And now at the domains of a hyperbolic functions, your x is an element of real number, whereby your x will never be equal to p. And then at your range, y is an element of real number, whereby your y will never be equal to q. Okay. Now, axis of symmetry. So now, what is axis of symmetry? Axis of symmetry, that is the line that cut the graph into two equal halves, or into two equal mirror images. Okay, the lines of symmetry are y is equals to x plus c1, and y is equals to negative x plus c2. So substitute the point PQ, substitute the asymptotes to calculate c1 and c2. Now let's look at the example number 1. They say consider the function f of x is equals to 2 over x minus 3 plus 1. So now the question number 1 is say write down the equations of the asymptote. So you will start here with this one. So y is equal to 1, and then your x minus 3 is equal to 0, then your x is equal to 3. Okay, then for you to calculate the coordinates of x and y intercepts, we have said that when calculating the x-intercept, y is equal to 0, and then the y-intercept, x is equal to 0, right? So, and then write down the range, the domain and the range. Sketch the graph of f clearly showing all the axes of asymptote. Okay, this is simple, guys. Okay, we said your x is equal to 3 and y is equal to 1. Those are your asymptotes. Now, for you to get y-intercept, I said your x is equal to 0. So where there is x, you put 0. So it will be y is equal to 2 over 0 minus 3 plus 1, which will give you 1 over 3, right? So in other words, your coordinate will be 0 and is 2, 1 over 3. And then x-intercept when your y is equal to 0. So here on y it will be 0. It will be 0 is equal to 2 over x minus 3 plus 1. So here your denominator is x minus 3. It means that you have to multiply throughout by the denominator of x minus 3 for you to get 0 is equals to 2 plus 1 over x minus 3. Then you remove the brackets here. It will be 0 is equals to 2 plus x minus 3. And then you solve for x. Your x will be x is equals to 1. So it means that your coordinate now is 1 is to 0. And then for the domain, I said x is the element of real number where x will never be equal to 0 to 3. And then on your range, it will be y is an element of real number whereby your y will never be equal to 1. Okay. Now for you to sketch a graph, this is very serious. You start by your asymptote here. Your asymptote here, you'll start by your vertical asymptote, x equals to 3. Then you draw your line here. Okay. Then your horizontal asymptote is y equals to 1. Then you draw a line here, right? And then now you plot the 2 points. 0 is to 1 over 3. 0 is to 1 over 3 is this point. And then another point is 1 is to 0. 1 is to 0. So it will be 1 is to 0 is here. So now you can just join the 2 points, right? And then you can just come and draw the other graph this side. Let's do example number 2. The diagram below represents the graph of f of x is equal to a over x plus p plus q. Point T is 5 is to 3 is a point on F. This is the point T here. Okay, now what is your Q here? Your Q here, it will be the horizontal asymptote, which is a 2. So your Q here is 2. Okay, and then what is your P here? Your P here is the vertical asymptote, which is at 4. So in other words, we've got P and Q. So we have to calculate the point of A. So here we've got P and Q. So we must now determine the point of A. So you just substitute the point 5 is to 3. So it will be 3 is equals to A over 5 minus 4 plus 2. Then you solve for A. That should be simple. Okay. We have said that P and Q are asymptotes. Then you substitute your 5 is to 3. Okay, then here it will be 3 is equal to A over 5 minus 4, which is 1. Okay, then A over 1, which is A. Then it will be 3 minus 2, which is A equals to 1. Okay, now let's look at the exponential function. Exponential function, general formula for exponential function is y is equals to A x minus p plus q. Now let's explore these properties. What is your A? Your A is also indicates the shape of graph. And then if your A is positive or rather greater than 1, you have got a growth, or in other words, your graph is increasing. Okay, so it will be like this. And then when your A is less than 0 and less than 1, you have got a decay. So in other words, your graph is sort of decreasing. So you have got a graph like this going down. Okay, now what is P? P is the horizontal shift. This P is the horizontal shift. Okay, when your P is greater than 0, or when your P is positive, it means that your graph has shifted to the left. And then when your P is less than 0 or rather negative, it means that your graph shifted to the right. And then now, what is Q? Q is your horizontal asymptote, whereby your y is equal to Q. This Q is your asymptote horizontal. Okay, and then it also indicates the vertical shift. When your q is greater than 0 or positive, it means that your graph has shifted upwards. And then when your q is less than 0, the graph has shifted downwards. Now, let's look at the intercepts. For you to get x-intercept, your y is equal to 0. And then for you to get the y-intercept, your y is equal to 0. Okay, now, on the domain, x is an element of real number, the range y is an element of q, asymptote is to infinity. Now, let's look at the example. It says sketch the graph of f of x is equal to 2x plus 1 minus 1. So here, by just looking here, what is your horizontal asymptote? It's negative 1. Already you know that. So in other words, the parent graph, which is 2 to the power x, it was shifted to the left by what? By 1 unit. Okay, so now for us to sketch the graph, your asymptote is y is equal to negative 1, the x-intercept, your y is equal to 0, so it will be 2 to the power x plus 1 minus 1 is equal to 0. Then you transfer this negative 1 to the other side, then you've got 2x multiplied by 2 to the power 1 is equal to 1. And now you solve for x, right? So you transfer this 2 to the other side, then you'll have about 2 to the power x is equal to half, right? You change that half into 2 to the power negative 1, right? So you've got same base, then your x is equal to negative 1. That's simple. So your y-intercept, when your x is equal to 0, so when there's x, you substitute 0, it will be 2 to the power 0 plus 1, which is 2 to the power 1 minus 1, which is 1. Okay, then you start by drawing your horizontal asymptote first. Then the coordinate here is negative 1 and 0. You've got negative 1 and 0, you plot it first here. Then the coordinate here is 0 and 1. So it will be 0 and 1, then you plot it here. Then you join the graph. That should be simple. Let's look at example number 4. Here they're saying that the sketch represents the graph of f of x is equal to a to the power x. Okay, now you have got your point B and A here. So they're saying that write down the coordinate of point A, where is A is here. So it means that now here at A, your x is 0, but we don't know the y-intercept. We know that the x-intercept is 0. So for you, if you can just say f of 0 is equal to a to the power 0, that should give you 1, right? So your coordinate for A, it will be 0 is to 1. How can we tell that the graph is 0 less than x or less than 1? Because our graph is decreasing. Determine A if B is the point 3, if this B is the point 3 is to 1 over 27. So you have to determine the value of A here. So you can just substitute this point here. So your y will be 1 over 27, and then your x will be to the power 3. Then you change this 1 over 27 into the base of 3. So it will be 3 to the power negative 1 to the power 3, right? So in other words, your exponents are equal, so you equate the base, right? Determine the equation of the graph obtained by if f is reflected by the y-axis. Okay, this is the y-axis, so if you reflect this graph, it will be on this side, right? Rather than the coordinate of the point of intersection, it will be also at A. Okay, let me take you through the solutions. So we said your A is 0 is to 1. We said that the graph is sort of decreasing function. Okay, for when you substitute the coordinate for x is 3 and then for y is 1 over 27. So you have to change this 1 over 27 into the base of 3, right? It will be 3 negative 1 to the power 3. So now the exponents are the same, then you equate the base. So you've got a equals to 1 over 3. So on number 4, you reflect it along the y-axis. So it means that now you have your equation will be f of x. Your original equation is f of x equals 1 over 3 to the power x, right? So when you reflect this equation along the line y is equal to x, you affect the x-intercept. Along the y-intercept, you affect the x-intercept. So it will be negative x here. Then you change this in the form of a base. It will be 3 to the power negative 1 to the power negative x. So you have got y is equal to 3 to the power negative, and negative is positive. So it will be 3 to the power x, right? And then you've got your point raised to 1 after reflection, where they will meet. So now let's look at the inverse functions. Let's look at the inverse functions. So here you've got steps. So the inverse function takes the y values or the range of the function to the corresponding x values or domain and vice versa. So therefore, x and y values are interchanged. Function is reflected along the line y is equal to x to give the inverse. So we reflect along the line y is equal to x. So the notation for the inverse of a function is f negative 1 to say that that's the inverse. So now let's look at the straight line. F is equal to mx plus c. That's the equation of a straight line. So after reflection, it will be f inverse. F inverse is equal to mx plus c. And both of them, they are functions, right? In other words, they are one-to-one functions. So now on the exponential function, so it will be f is equal to a to the power x. So the inverse, it will be logarithmic function. So in other words, it will be f inverse is equal to log a x, right? So and then both of them, they are still functions. Now let's look when you get a parabolic function, f is equal to a to the power x squared. Then when you get the inverse, it will be f inverse parabolic functions. Then the original function is a function. Then the inverse of a parabolic function is not a function. For you to make it a function, you have to restrict the domains, right? Then in other words, you have to restrict the x values, right, of the inverse. The at x is greater than 0 or x is less or equal to 0. Now let's look at the example number 5. Given that f of x is equal to 2x plus 6, that's saying that determine the inverse, right? For you to determine the inverse, so it will be y is equal to 2x plus 6. Then you exchange the x and y values. Then it will be x is equal to 2y plus 6. Then you solve for y. Then that should be simple. Okay, and then on number 2, they're saying that sketch the graph of f of x, the inverse of f, and then you also draw the line y is equal to x on the same axis. Okay, now for you to get the inverse, you swap x and y. So the original equation is y is equal to 2x plus 6. You said that, then you swap x is equal to 2y plus 6, right? Then you solve for y. You make y subject of the formula. Then you transfer it will be x minus 6 equals to 2y. Then you divide both sides by 2. Then your y is equals to half x minus 3, right? So now when you just say f inverse is equal to 1 over 2x minus 3. So for you to get to plot this graph, start by drawing a line y is equal to x, right? So and then you have got original function as y is equal to 2x plus 6. So here you have to find the x-intercept when y is equal to 0, the y-intercept when x is equal to 0. Then you'll find that when your x is 0, your y is 6. When your x is negative 3, then your y is 0 here, right? Then you plot the points, then you join them. So for you to get the coordinates of an inverse, right? If here the coordinate was 0 is to 6, so on the inverse it would be 6 and 6 is to 0 here, right? And then if here is negative 3 is to 0, so it means that on the inverse, you just exchange the coordinates, it will be 0 is to negative 3. So it's somewhere here. Then you join the lines, and then y is equals to 1 over 2x minus 3. So another example, 6, given that f of x is equals to 2 to the power x, doesn't that draw the graph of f of x is equals to 2 to the power x, show at least 3 points on the sketch. Okay, here you just use a table. You have a x and y on the table. Then your x will start at -1, 0, and 1. Then you get the y values there. Okay, then draw on the same system of axis the graph of inverse. Right, the inverse of f. Write down the equation in the form of f inverse y is equals to. So this should be simple. Okay, you start by drawing a table, then you've got x, here you've got y, or f of x. Then when your x is -1, your y is 0.5. When your x is 0, you've got 1. When your x is 1, you've got 2. Then you plot the coordinates. So you can just start here, -1 and 0.5. You put a point here, 0 and 1. You put a coordinate here, and then 1 is to 2. You put a coordinate here, then you join the lines, right? So now for you to draw the inverse graph, for you to get an inverse graph, so here the coordinate is 1 is to 2. So for you to make it an inverse, you exchange, so it will be 2 is to 1. So you put your coordinate here, 2 is to 1, and then here is 0 is to 1, it will be 1 is to 0. So you put a coordinate here, then here it will be 0.5 is to -1. 0.5 is to -1. You put a point here, then you join the coordinates, right? We were not told to draw a line y is equal to x here, so just leave it like that. Okay, then for you to get the inverse, the original function was y is equals to 2 to the power x, then you exchange, it will be x is equals to 2 to the power 1, then you solve for y, right? It will be y is equals to log 2, right? The base log 2x. Okay, now let's look at the exam questions. The exam question 2018 November, paper 1, right? You were given the f of x is equal to -1 over x minus 1. I think that was question 4 for 2018. Okay, write down the domain of f. So it will be x is an element of real number, right? X is an element of real number whereby x will never be equal to 1. Then write down the equations of asymptotes. Then your x minus 1 is equal to 0, which will be x is equal to 1, and then your y is equal to 0, right? Then you sketch the graph here. So when you are sketching the graph here, guys, you have to start by getting the y-intercept. So you just put the y-intercept. So y-intercept when x is equal to 0, so you'll have a -1 over 0 minus 1, which is -1, -1, which is 1. So you've got coordinate as 0 is to 1, okay? And then there are no x-intercept here. So x-intercept, you cannot get x-intercept here. So your graph will be, you just start by putting the y is equal to 0, the asymptote y is equal to 0, and then x is equal to 1, and then you draw a graph. It should be simple. So if you've got any question, you will put on the comments. This should be simple. Now the other question, exam question again, 2018 November paper 1. 2018 November paper 1. In the diagram below, the graph of f of x is equal to ax squared is drawn in the interval x less than 0 is true. Everything is on the negative side. The graph of inverse is also drawn. And then you've got P is a point on F and R is a point on the inverse. Right here is a graph of F and then here is a graph of inverse. So the same that is a F inverse a function. Motivate your answer. So F inverse is a true, yes, it's a function. Then you have to motivate your answer because see when you use the vertical line test, for every x-intercept there is only one corresponding y value. If R is a reflection of P in the line y is equal to x rather than the coordinate of R, so this is the P is reflected along the line y is equal to x, the same that rather than the coordinate of R. So along the line y is equal to x, you just exchange, it will be, your R will be negative 12 is to negative 6, just exchange the coordinates. And then calculate the value of A. The value of A here is on the graph f of x. On the graph of f of x, so it should be, you just substitute the point P, right? You just substitute the point on the graph, then you solve, it will be negative 12 is equal to A x to the power negative 6, then you solve for A. That should be simple, it's pure math, simple. Okay, and if you've got any question, write this question, you can put your question on the comments. Okay, thank you guys. And one thing, don't forget to like, share, and subscribe to our channel. Thank you. I will see you soon.